We're going to talk about kinetics, and that is chapter 14. So reaction rate is the speed of a reaction, and it's going to depend on the frequency of collisions. In other words, the more collisions you have, the faster the reaction is going to take place. Now, the collisions do have to have enough energy to stretch the bonds and correctly orient the molecules to, in order for new bonds to form. So they have to have enough energy, and they have to be situated in the right way for the reaction to happen. Now, factors that affect reaction rate are going to be the physical state of the reactants. In other words, the more collisions that can happen, the faster the reaction is going to be. Reactants that are in different phases are very limited to the area of contact. For example, a lot of times if you take a solid and you dissolve it in water to make it an aqueous solution, the reaction will happen much, much faster because you've already broken that down into ions. Another factor is the concentration of the reactants. The higher the concentration, the faster the reaction. You've got more moles of stuff in there. Another factor is the temperature. When you increase the temperature, you increase the kinetic energy, and that's going to mean more collisions. So the reaction is going to happen faster. And we can also add catalysts in there, and we'll talk a little bit more about catalysts later in the chapter. But that's going to affect the mechanism or the kind of collisions that happen. And an example of a catalyst are enzymes that happen in your body. We're going to talk about the collision model in 14.5. The goal of this was to develop a model that explains why the rates of reactions increase as concentration and temperature increase. So in order for molecules to react, they must collide. That's the whole basis of the collision model. The greater the number of collisions, the faster the rate. The more molecules that are present, the greater the probability of collision, and the faster the rate. So the higher the temperature, the more energy there is available to the molecules, and so they're going to move faster and they're going to collide more. Now here's the complication. Not all collisions are going to lead to products. In fact, just a small fraction of collisions lead to products. So there are three factors that affect the rate at which a chemical reaction occurs, and we're going to look at those. So we have our orientation factor. In order for the reaction to occur, the reactant molecules have to collide in the correct orientation, and they have to have enough energy to form their products. So if we consider this equation here, there are two possible ways that the chlorine atoms and the NaCl molecules can collide. One is effective and one is not. So this picture that I'm going to show you is in your textbook. So the green, that's your Cl. So we have our NaCl molecule here with the red, green, and blue. So an effective collision is when the two chlorine molecules hit, forming that Cl2 molecule and the NO molecule. If the chlorine does not hit the Cl, it's what we consider ineffective. And so it's basically just an elastic collision where, this chlorine hooks up here with the nitrogen, and you can see that all it's done is just change positions, really. So we're going to consider the rate of collisions between the reactants, the percent of the collisions with the proper orientation, and the percent of collisions that possess enough energy, or the activation energy. So we're going to talk about all of these things. So for a reaction to take place, the molecules have to bump into each other. The more reactants there are in a system, the more collisions there's going to be per second. As the particle size increases, your surface area is going to decrease. So, if you've got, if you increase your surface area also, that's going to increase your collisions. When there's more particles to hit, then you're going to have more collisions. And of course the temperature increases the energy. They're moving faster and faster. And so by doing so, you're increasing the average velocity of the particles, so the collision rate is going to increase as the speed increases. Now, remember that not every collision is going to trigger a chemical reaction, so just keep that in mind. So here's another diagram of the same, well, a similar reaction. So there's no reaction here if our orientation looks like this. If one oxygen is colliding with a chlorine on this molecule and another oxygen down here with this molecule. Again, the chlorines are what need to collide together so that we can form that Cl2 molecule.